So in this video, we're going to take a look at some circle theorems and some work with circles that you're going to be able to use to solve some problems. So first of all, we'll take it step by step and show you each idea and then an example of how it could be used. So the first thing to say is if we cut a circle all the way across the middle going through the center, we have a diameter. And if I ever join the 2 points of from each side of the diameter together, we are always going to have a right angle. Okay, so that would be a right angle. If I did it over here, it would still be a right angle. If I did it up here, that is still going to be a right angle. Now, I'm not proving things in this video. There is a proof in the textbook, but that is the idea. So how would we use that? Well, let's have a quick look at a couple of simple examples. We've got situations here where you've got to find the missing angle. So straight away here, we can see we've got a diameter. So A is going to have to be 90 degrees. And if A is 90 degrees, well, all three angles on a triangle add up to 180. So if I wanted to work out B, that is going to be 180, take away 90, take away 25. So if I work that out, I'm going to have B is 65 degrees. Okay, let's take a look at the second one. Well, it's exactly the same situation. This time we'll do B first. B is 90 degrees because we have that diameter, right? Okay, so that side is going to have to be 90. If I then wanted to find out A, that is going to be 72 degrees because I've got to do 180, take away the 90 and the 18 is going to leave me with 72. So that's the first simple theorem we can think about when we're looking at angles in circles. Now, another thing that's very useful is to understand tangents. Now, a tangent is a line that touches a circle once, as in the diagram you can see in front of you. And if we connect a radius from the center to a tangent, it is always going to be 90 degrees. And again, we can use that in lots of questions about circles. Right, so let's take a quick look at what a question might look like in a simple sense. So the first one on the left-hand side, again, we can see straight away that A is going to be equal to 90 degrees because it is a radius touching a tangent. If I wanted to work out B, I am going to do 180, take away 90, take away 25, it's going to give me 65 degrees. Now, looking at the right-hand picture, this is a bit more tricky. Can we work this out? Well, it's a quadrilateral shape. I think that it would be much easier if we split this into two. Now, if I have two tangents, what we've got there is we've got congruent triangles either side of that red line. They're both going to be the same because they're both radiuses, right? Okay, so let's just consider one half of that. Well, we know that that angle there at A is 90 degrees. If I do 106 divided by 2, I'm going to get 53 degrees there, look, okay? So I can work out half of the original angle A, which I've just put there, look, on B, by doing 180, take away 90, take away 53. Now, if I do that, I'm going to see that that part there is 37. So if I double that and have another 37 the other side, I get A is equal to 74. There's lots of ways of doing this question, but that's a nice technique there. Okay, now other things that can happen is that we can get isosceles triangles because think about it. If we have two radiuses, well, radiuses are always the same length, right? Okay, they're always the same length. So if we connect them up, we're not going to sort of have any old triangle. We're going to have isosceles triangles, which means that these two angles are going to be the same as well. So let's now take a look at some nice simple questions that help us to understand how we can use that particular property. So take a look at that left-hand side A. Well, if this is a circle, then the two sides I've indicated with red dashes are going to be the same length, which means that we're going to have the same angles there. A is going to be 20 degrees. So as it's a triangle, we can now work out B, because we're going to have the 180 from the whole triangle, take away two lots of 20, it's going to leave us with 140 degrees. So B is 140 degrees. Let's take a look at that right-hand triangle. So again, if I have a triangle that adds up to 180, well, I've already got 130. So if I do 180 take away 130, I'm left with 50 degrees. But because these lengths are the same and the angles A and B therefore are exactly the same, to find them out, all I've got to do is take that 50 degrees and divide it by 2, because they've got to be the same. That's going to be 25 degrees. So A is 25 degrees and B is 25 degrees. Okay. Let's move on and let's look at some other examples. Right, okay, so next one. If we have a chord, and a chord is just a line that cuts a circle. So look, P to Q there is a chord. So if we take from each of those 2 points, P and Q, lines, and connect them to any part of the circle, so we're always going to get the same angle, right? Okay, so in this case, A is the same as B. I could do it again. Let's do it over here, right? Those angles are the same as that angle there, C. They're also the same there, right? It doesn't matter where you draw the lines, they're always going to be the same. So if that's true, let's take a look at some examples that might help us to work that out. We'll just do this left-hand side one here. So think about the answer. Okay, well, clearly A has to be 35 degrees as well. It might not look like the same situation, but I can very easily draw a chord here, look, and then we've got that thing happening. We've got the same 2 points connecting to an angle, so they're both going to be 35. A is 35 degrees. Now, another property we have is to do with angles from the center. This is the same picture, right? But it's interesting to see that if I have an angle A that from 2 points, right, to the outside of the circle, there's a relationship between that angle and the angle to the center. If that angle was A to the outside, then the angle to the center is double. So that angle would be, for example, 2A. Let's take a look at that second example now and see if we can work out what the angles are here. So using that property, we've got 2 points going to the outside, look, and going to the center. This is exactly what was above. So that means that the angle to the center is double the angle to the outside, which means A is 2 lots of 25. So of course, A is 50 degrees. If I wanted to find out B, well, that's going to be 25 degrees. From that previous rule, they're connected from the same chord, look. So B is going to be 25 degrees as well. Okay, let's move on to our final property for this video. And this shape that is inscribed in a circle there is known as a cyclic quadrilateral. Okay, now any quadrilateral that can be drawn like this, where all 4 corners are sides of, touch the side of a circle, is known as a cyclic quadrilateral, and we have the following property. Opposite corners add up to 180. So D plus B is 180. A plus C is 180. Okay, so we can use this in questions just like what we've got here below. So let's take a look, right? Okay, so if I'm looking at that left-hand side, part A, I can tell you straight away that A is going to be 180, take away 60. Well, A is going to be 120. If I wanted to work out what B was, it's the same principle. It's going to be 180 take away 105. So B is 75 degrees, right? They have to add up to 180. The reason for this, if it wants us to give a reason for our answer, is because the quadrilateral is cyclic, so opposite angles add up to 180. Just to reinforce this, if we take a look here at part B, I could work out C very easily by doing 180 take away 31. So that is 149 degrees. To work out D, I could do 180 take away 57. Well, that's going to be 123 degrees. That principle works every time. Now, in the question set, you may have to combine these rules, but I think that's probably enough for this video.